Hi everyone, I'm Yashwantem, student of SCCA Bangalore. My branch is CSE, my class is Devu, my USN is 1VE22CS187. Subject is Applied Chemistry for CSE stream. Subject code is BCHES202. What is corrosion? Corrosion can be defined as the destruction or deterioration or loss of metal or alloys by surrounding environment through chemical or electrochemical reaction. The process of rusting, the oxygen plus iron plus water, it causes the rust. Types of corrosion prevention or control methods. Corrosion can be controlled by preventing the formation of galvanic cells on the surface of metals. The methods to control corrosion can be classified as design and selection materials. Second one, protective coatings. The protective coatings are subdivided into inorganic coating and metal coating. And lastly, cathodic protection. Protection coating. Corrosion is prevented by the application of protective coating on the surface of metal, thereby the metal surface is isolated from the corrosive environment. Important types of protecting coating are metal coating and inorganic coating. Metal coating. The process of coating base metal with a layer of protective metal is known as metal coating. There are two types of metal coating. Firstly, anodic coating and cathodic coating. First one, anodic coating. The coating metal is anodic to base metal is known as anodic coating. Example, galvanization. Galvanization. The process of coating zinc on the base metal Fe steel surface by hot dipping is known as galvanization. The galvanization process is carried out as follows. Firstly, the metal surface is washed with organic solvent CCl4, toluene and benzene. Next point, to remove organic matters. Next, the metal surface is treated with dilute H2SO4 to remove rust and other deposits. Next, then it is well washed with water and it is air dried by passing hot air. The metal is treated with a mixture of zinc chloride and ammonium chloride. Next, solution which prevents the oxidation of the coated metal. Next, then the metal is dipped in the molten zinc at 4500 C. Excess of zinc on surface which is removed by the passing a pair of hot rollers which remove excess of zinc and produce thin coating. Here you can see galvanizing process. Firstly, caustic cleaning, rinsing, pickling, and again rinsing, flux solution, drying, zinc bath, cooling, at last inspection. Inorganic coating. These coatings are produced at the surface of metal by chemical or electrochemical reactions. Example, anodizing and phosphating. Anodizing. Anodizing coatings are generally produced on non-ferrous metals like Al, Zn, Mg, and their alloys by an anodic oxidation process in which the base metal is made up of anode. Anodization of aluminium. When aluminium metal is made up of anode in an electrolytic bath with H2SO4 or chromic acid as the electrolyte, a thin layer of Al2O3 is formed on the surface of. This process is called as anodizing or anodic oxidation of aluminium. The porous coating is obtained by anodic oxidation. It is carried out by making it anode in an electrolytic bath containing a suitable acid like chromic acid or H2SO4 at 35 to 40 degrees Celsius. Next, a plate of lead or stainless steel is made with cathode. Next, when current of moderate density is passed, the O2 liberated at the anode combines with it to form oxide, which takes the form of thick film, Al2O3, deposits on the surface of the object. The coating is slightly porous and it is sealed by dipping in hot water. Next, Al2O3 gets hydrated to Al2O3. Next, H2O which occupies more volume and hence protects the metal from corrosion. The coating is slightly porous and it is sealed by dipping in hot water. Al2O3 gets hydrated to Al2O3. Next, H2O which occupies more volume and hence protects the metal from corrosion. Here you can see the reaction of a metal dipped in an electrolytic solution. Cathodic protection. Cathodic protection is a technique of offering protection to a specimen against corrosion by providing electrons from an external force. There are two important methods of cathodic protection. Firstly, sacrificial anodic method. Second one, impressed current or voltage method. First one, sacrificial anode method. Sacrificial anode method involves the use of metal which is anodic to the specimen. In this method, the metallic structure to be protected is connected to a more anodic metal using a metallic wire. More active metal gets corroded while the parent metallic structure is protected from the corrosion. Example, when the steel metal to be protected, it may be connected to a block of magnesium of zinc. In such case, steel acts as a cathode and is unaffected, where magnesium or zinc act as an anode and undergo sacrificial corrosion. When the sacrificial anode gets exhausted, it is replaced with the new ones. The commonly used sacrificial anodes are Mg, Al, Zn and other alloys. Example, first point, production of ship's hull by fixing zinc plates. Second, production of an underground pipeline with a magnesium anode. Impressed current method. In impressed current method, the electrons are supplied from a source of direct current. In impressed current method, the metal to be protected is connected to negative terminal of an external DC power supply. The positive terminal is connected to an inert electrode such as graphite. Under this condition, the metal acts as a cathode and hence does not undergo corrosion. The inert electrode acts as an anode, but it does not undergo corrosion because it is inert. Thank you.